Have you ever stopped to think about whether you're paying for the exact same prompt over and over again? I mean, think about it for a second. If you're building AI applications, you probably have these massive system instructions, complex developer guidelines, or maybe like a 50-page reference document that you're sending to the language model with every single user query. So you really have to ask yourself, do you realize that these massive system prompts might be quietly inflating your API bills with completely redundant processing?
And that brings us to a really eye-catching number, 90%. Google Cloud's Vertex AI has this feature called context caching, and it promises up to a 90% discount on input tokens. Now, on paper, that sounds like an absolute magic bullet for your cloud budget, right? But is it really? Well, today we are going to explore the myth versus the reality of that incredible discount.
Welcome to this explainer. I am so thrilled you're here with us. Today, we are going to completely demystify cloud economics, unpacking what we call the context caching trap, optimizing Vertex AI costs. We're going to look into the counterintuitive reality of how caching actually works behind the scenes and why a feature designed to save you a ton of money can, if you misconfigure it, actually end up doing the exact opposite. All right, so here is our roadmap for this explainer. 1. Non-cached system prompts. 2. How context caching works. 3. Savings versus storage costs. 4. When caching fails. And finally, 5. Smart optimization strategies. Let's get right into it.
Section 1. Non-cache system prompts, or what I like to call the burden of redundancy.
Let's really agitate the problem here. Imagine you've got a customer support chatbot, and it's loaded up with a massive 50,000 token knowledge base. In standard processing, every single time a customer asks a simple 10-word question like, hey, where's my order? You are forcing the API to process all 50,000 of those background tokens plus the new 10 tokens every single time. It is a massive waste of compute and money. But with cache processing, the API actually stores your massive background context server-side. It treats it as a reusable prefix, meaning it only has to process the tiny new query. It's faster, it's more coherent, and it is explicitly designed to save you a fortune.
Which brings us nicely to Section 2, how context caching works.
So unlike implicit caching, which just happens automatically in the background for some models, explicit context caching puts you firmly in the driver's seat. Basically, it's a mechanism where you pass content to the model once, store those input tokens on the server side, and then just reference them in your subsequent requests to guarantee cost savings. You are essentially building a temporary, highly accessible memory bank for your model, giving you direct intentional control over what is stored and exactly how long it stays there.
The implementation is actually a remarkably simple 3-step technical workflow. Step 1 is creation. You send a post request through the Vertex AI API with your massive document or system prompt. Step 2 is reference. The API then hands you back a unique resource name. In all your future chat requests, you just pass that name instead of uploading the entire document all over again. And step 3 is management. You set a time to live, or TTL, to dictate exactly how long that cache stays alive, or you can just delete it manually. Pretty simple, right?
But wait, moving on to Section 3, savings versus storage costs. And yeah, there's a catch. First, we have to look at the shiny object, a 75 to 90% discount on input tokens. When you reference a cache token instead of paying the standard input rate, you're paying a tiny fraction of the cost. For high-volume applications that are just getting hammered with user queries all day, this looks unbelievably attractive. It honestly feels like you're hacking the cloud billing system. But here is the other side of the equation. $1 per 1 million tokens per hour. This is the insidious hourly storage fee. Google literally charges you to keep those tokens warm and ready on their servers. So if you cache a massive context and forget to set a proper expiration time, this hourly meter runs 24/7, and it runs whether you are actually querying the model or not.
All right, Section 4, when caching fails. Let's look at the actual math.
We are going to ditch the hypotheticals entirely here. Let's look at the concrete math of a 50,000 token context. And this is based on real-world data from the developer community. In a low-volume scenario, say an internal tool getting maybe 15 queries a day, standard processing costs just 38 cents. But turn caching on? That hourly storage fee makes your costs jump to $1.21. You are literally losing money by trying to save it. However, look at a high-volume scenario of 100 queries a day. Standard processing balloons to $38, but with caching, just $1.37. That is a massive 96% drop. So this creates a definitive tipping point.
At low query volumes, the caching costs actually outpace standard processing. Because here's the secret, caching is entirely a volume game. If you do not cross a specific threshold of queries per hour, the cost of storing the tokens completely destroys any discount you get on processing them. This is exactly the trap that so many developers fall into.
Which leads us to our final part, Section 5, Smart Optimization Strategies. Let's deliver some truly actionable frameworks, and we'll start with a super common misconception about combining discounts. A lot of folks think they can use the Batch API alongside caching to get some sort of crazy stacked 95% total discount. Well, absolutely crucial point here. Discounts do not stack multiplicatively. The way it actually works is the 90% cache discount applies first to the cached tokens. Then, the 50% batch discount applies strictly to the remaining non-cached tokens in your prompt. It's still highly efficient for overnight jobs for sure, but you have to calculate it correctly.
Let's quickly summarize the golden rules of context caching with a final rapid-fire developer checklist. Number 1, ensure you meet minimum thresholds. For instance, Gemini 2.5 Pro requires at least 4,096 tokens before caching even activates. 2, rigorously manage your time to live. Please don't leave caches running overnight if your users are fast asleep. 3, only cache for high query volumes so you can actually beat that storage cost. 4, do not mix this with provision throughput. They completely conflict. And 5, use caching for static data, like reference manuals, not rapidly changing data feeds that require you to constantly rebuild the cache. I want to leave you with this final provocative thought. Is your AI architecture generating business value, or is it just generating invoices? Context caching is an incredibly powerful tool in Vertex AI, but it absolutely requires precise strategy. I highly encourage you to go audit your endpoints, check those time-to-live configurations, and run the math on your query volumes today. Because if you master the cache, you master your scale. Thank you so much for joining me on this explainer, and keep building smart.